Now that we've found the work done by friction, let's find the work done by the applied force. Okay, we'll do the same thing. So let's go for work done by applied force. And that's just F. So now we have that the work done by force F is equal to the force times the displacement times the cosine, not theta. Don't forget that this angle belongs to the force. So we need another Greek letter. Let's go for phi. And let's think about what phi is. Well, here's the direction of motion. Here's the head of my force vector. So the angle between those two is 0. So the work is maximized. Okay? So that means the work done by the applied force is simply applied force times distance, because theta is 0, the cosine of 0 is 1. And then for this one's super simple because I do have the applied force, 150 newtons, and then the displacement is 7.06 newtons. I'm sorry, meters, not newtons. So the work done by the applied force is 1,059 joules. Positive as we expected. Now let's find the force done by gravity. I mean the work done. I don't know if I said force, but if I did, I meant work. Work done by the force. I'm just going to say gravity, okay? Gravity. No, I have to say force of gravity. Okay. Let's think. The component that is affecting the motion from these two, from the y and x direction, is the one along the x. Think about it. If we were to remove this force, this would go down the incline, and the component responsible for making this block slide down the incline would be the one along the x direction. And we can apply trigonometry again, do the same thing, but now we have the opposite side, so we would have the sine. So that means this is mg sine of theta. Okay? So we have that the work done by gravity is equal to the component of the weight along the x direction. So let's say mgx times the distance times the cosine. Let's go back over here. Notice how the x component of the weight and friction have the same direction. So I'm going to use a third Greek letter, but the angle is going to be the same as the force of friction because it's 180. It's doing negative work. So I'm going to say beta. And I know that beta is 180 degrees. So therefore, the work done by gravity is minus mgx times displacement, because the cosine of 180 is negative 1. Furthermore, the work done by gravity after we use trigonometry is negative mg. Oh, I forgot the displacement. My mistake. mgd times the sine of theta. It's minus 10 kilograms, 9.8 meters per second squared. And displacement is 7.06 meters. And the sine of 35 degrees. Desmo says this is equal to negative 396.846 joules. Don't forget that the reason why we knew the work done by gravity was due to this component is just imagine what happens if we remove this force. This slides down the incline, and it's because of the x component, the component along the incline. So now, how do we find the net work? Let's go back to the very first relationship we wrote down. So we need to combine, add all of those works. So all of them. So then the net work, it's going to be the work done by the applied force. And that one was, what was it? Yeah, 1059. So 1059 joules minus, because we have a negative work done by friction. So that one was 190.996 joules minus the work done by gravity. That was 396.846 joules. And we combine all those, so the net work is equal to 471.157 joules. And because the net work is equal to the change in kinetic energy, then the change in kinetic energy is just the same thing. And that's it.